whose derivative is 0. Maybe C1, maybe C2 here. Okay. Then back to the original one. Oblique, oblique, oblique 2. Back to the original situation. So this is C1, C2. Okay. This is the idea to prove, use Rawls theorem to prove mean value theorem. Let's do this. Since the proof is easy, so I will show the proof here. Under these two conditions, let's define a new function. Define h of x to be f of x minus a linear function or the same. Then this new function h is continuous on the closed interval a b. Why? Because this is continuous on here, so continuous from the right at a, continuous from the left at b, and then continuous everywhere, interior to interior of yes AB. And this is a polynomial function, a linear function, a polynomial function which is continuous everywhere. So continuous function minus the continuous function is a continuous. Same. By the differentiation formula or property. This one is differentiable on this open interval. And this function is a linear function, is differentiable everywhere. Of course, this condition is satisfied. Okay? Finally, h of a. If x equals a, fa cancel. A minus a, 0. H of b, b minus a, cancel. F of a cancel. HB, FB also cancel 0. Yes. That, what? Yes. Okay. This is H. So, by Rawls theorem, H prime of C, H prime means F prime minus, this is 0. Okay, H prime of x equals F prime of x minus, this is constant. By distributive law, the second term is also a constant. So this is exact, this number times x, the derivative is f of b minus f of a over b minus a. Therefore, h prime c equals 0 means f prime c minus this one equals 0. Equals 0 means they are equal. Okay. So in order to find C, we use this curve minus this curve and find C back. Okay? So sometimes important theorem, if you know the detail, the basic things, you can see, oh, though Rolle's theorem is a special case of this one, means this one implies that one. But we can prove this by using Rolle's theorem. See? Use Rolle's theorem to prove that one. And use that one to prove Rolle's theorem, because Rolle's theorem is a special case of this one. When f of a equals f of b, this is the difference here is 0. So these two theorems are equivalent, logically equivalent. So if you say mean value theorem is a special case of Rolle theorem, it seems right. It seems right, but not so clear. This means mean value theorem can be proved by using Rolle's theorem. Okay, these two theorems both are important. Both are important. Example 1. The physical meaning of Rolle's theorem is that the physical meaning of Rolle's theorem if a particle moving along a straight line, and at some time, okay, the position function is s equals f of t. There is a clock t. Suppose this particle moving in 2 instants at the same position. For example, at some time A and a B, maybe here. According to Rolle's theorem, if this particle moving the velocity and there must be a some instant C, the velocity is 0, because at the same position, move to the right, move to the left, there must be somewhere turn around. Here, F prime C is 0. Okay, this is the Rolle's theorem. Rolle's theorem. Turn around. So here, there's some time C between A and B. At A, maybe this is FA, okay. This FA, FB. Of course, this particle is moving on this line. For clarify, I use this not above the straight line. Mean value theorem. Example 3. Example 4. Example 4. Okay. Example 4. About the mean value theorem. If someone at some time A at a position f of A, at time B at a position f of B, then the average velocity on this time interval will be f of B minus f of A over B minus A. This is the average velocity. 平均速度 average velocity on this time interval. Then according to mean value theorem, there must be some time your instantaneous velocity exactly at some position. Your instantaneous velocity is exactly the average velocity. Okay. Then, yes, in fact, there are many places we use this theorem to give you a fine, right? How to say that? For example, at 8 a.m., you were here. At 9 a.m., you were here. And the distance between these two places are 110 kilometers. Of course, there are many camera to catch whether you overspeed or not. If you only use 1 hour, then you move 110 kilometers, then must be at some time C between A and B, your velocity is if the limit of speed is 100, then you will get a red, how to say that, ticket or traffic punish. I don't know how to say that in English. You know, by mean value thing, you must be over the limit, speed limit. So this is also an application of mean value thing to the real case, the real world. Okay, the rest examples I will solve for next week. Okay, see you next week. Bye.